Okay, we are moving on to 8.6 radical expressions. Radical. And when I say radical, I mean things like that, square roots and stuff like that, with maybe a 3 cubed roots, or maybe a 4 fourth root, something like that. And did you know that fourth root is the same as something to the 1/4 power? Or a square root is the same thing as something to the 1/2 power? Or a cubed root is the same thing as x to the 1/3 power? Well, if you didn't, you do now. You do now, right? So your goal of this is to be able to find the domain of rational, which should be rational, it should be radical. So make that change. Functions from different transformations, as well as evaluating rational. Again, not rational. That's ridiculous. They're radical. Radical functions right there. I gotta have an editor. I definitely do. Okay, so the first question I just want to show you is what a radical function looks like. At least I put it right there. Okay, and I got one right over here. There's a radical function. It has kind of nice, starts at maybe this point. It doesn't have to start at this point, and it just kind of goes up like this. And in fact, a radical function, you know what it is? It's actually the inverse of a quadratic function. And you know what quadratics look like. See? If you just kind of hide this section of it, doesn't it look like a radical function on the side? And if you keep this radical function going like this, doesn't it look like a quadratic function on the side? That's just the inverse of it. And the inverse is really just if you drew the line y equals x. It's just a mirror image on both sides of that line. Okay? And a radical function, it would be something just like this. F of x is equal to square root of x. So that's how you do what a radical function would look like. And this is the graph of a radical function. In the next section, what I'm going to do is I'm going to show you how you can find the domain of a radical function.